My name is Giuseppe Maxia. I work at VMware. I work in quality assurance, and for this reason, I have a quality two qualities actually. First, I like breaking things, and the second one, I always doubt. I don't believe whatever they tell me that it should work. So I have a compulsion to test on my own whatever they tell me. I have a blog, datacharmerblogspot.com, where I talk about this matter, and a Twitter account, datacharmer, where you will find the slides later on. So what is this skeptic thing that you see in the title of the presentation? Skeptic is a person inclined to question all accepted opinions. So why did I put that in the title? The thing is, whenever a new version of MySQL, MariaDB is announced, there is a lot of marketing say, we have this new thing, this works, this is beautiful, and sometimes it is like that, and sometimes it's not. So follow me in this excursus where we look at everything that was claimed and see if it's true. So we're going to look at GTIDs, multi-source replication, parallel replication, and group replication. Things that should work in MySQL 5.6, 5.7, 8.0, and MariaDB 10.0 and 10.1. Everything that we look at here will be in the framework of monitoring. The reason is that monitoring is probably the most important thing that you have in replication, because if replication is working and is very fast, but you don't see what it's doing, then it's basically useless. So the contents of this presentation is mostly, let's see how good monitoring for this feature is. Let's start with GTIDs. Very quickly, the problem with GTIDs, so the reason why we have GTIDs is that the traditional way of representing transactions in MySQL, it's with a combination of binary logs and offset position, which is convenient up to a point, but we need something more dynamic than one file and position. Just to have a quick example, if you have a hierarchical replication, you see that the masters below the main master may not have the same file name for bin log, and of course we'll have different positions for bin log. So we are talking about the same transaction that may be represented by different files and positions. Or we have different transactions. But just looking at this, there is no way of saying we are all at the same transaction. When we use GTID instead, this is where the situation is much more clear. We have one specific GTID in the main master, and then we have either the same GTID or a lower one in the other masters. So we know how fast the replication is going, how complete the masters and the slaves are. So how is it implemented? In MySQL 5.6 and 5.7, this is made with the server UUID, so a long string, and than the number of the transaction itself. There are a few restrictions. It only works with transactional engines. There are a few statements that are not allowed, and you cannot have temporary tables within a transaction. In MySQL 5.6, there was another restriction that you should have always log slave updates, and this was improved in 5.7. So what is good about this? The good is that you can have tools that will allow you to do maintenance of the database or the replication system very easily. So there are tools that will do the failover and transaction tracking for you without need for you to look at the binary logs. The bad is, first, it's not enabled by default, so you need to do that manually, and sometimes there are side effects. The thing that I dislike mostly is that it's hard to read for humans, so if you have to tell the transaction ID to somebody by phone, good luck with that. Another thing is that there is little integration between GTID and the existing software that deals with replication. For example, the crash save tables in the MySQL schema, they don't talk GTID, they only talk binary log file and position. In MySQL 5.6, there is also the mandatory log slave updates. In MySQL 5.7, you can enable GTID dynamically. So if you have a running server and you say, I want to enable GTID without stopping the server, you can do that. It requires a long procedure, so there are 9 steps. You have to read the manual and follow the steps one by one. It works. I wish there was just a button to say GTID, yes, no, but it's not that simple. So, what is different when you look at the master and you are using GTIDs? The thing that you see in show master status is that you have executed GTID set, which tells you what the master has produced. Or there is a variable, a global variable named GTID executed, which has the same content that you see in the show master status. In my opinion, this is not a good name for the variable, because executed gives the idea of something that was produced, received, and then committed. Instead, this is something that is produced by the master. But we'll see later that this is not always the case. In show slave status, there is something different. So when you are using GTIDs, you have retrieved the GTID set and executed GTID set. This is wonderful. This is the place where you have the information at once, so you see which transaction was received, meaning that is in the relay logs, and which transactions was committed. So here, just looking at these 2 lines, you see if your slave is lagging or not. So if you have the same numbers there, it means that the slave has committed everything. If you see that the executed is lower than retrieved, so you have a problem, or you stop the slave. You know that the replication is not working fine. So when you look at the tables that you have in the MySQL schema, you see that these tables that were created before GTID was implemented in MySQL 5.6 still don't have information about GTIDs. MariaDB. MariaDB has GTIDs, and instead of using UUIDs, it uses a combination of domain ID, server ID, and number. I wish MySQL had used something similar because this is usable by humans. Anyway, so there are two things that I like about this implementation. The GTID is simple, and it is enabled by default. So you don't have to think, did I enable it? Or should I do something special to enable it? It's just there. No known limitations, so all statements should work. There is lack of integration with all the replication coordinates. So you will see coordination only in show slave status, and that's it. So what do you see in the master? You don't see anything special in show master status. And there are variables, so GTID binlog pos and GTID current pos that tell you what GTIDs are being processed. It's very simple, but at the same time, there is not a lot of information there. So what do you see in the slave? You see GTID IO pos. IO, you know that the replication has two threads. One is the thread that gets the data from the master into the relay logs, and one is the thread that takes data from the relay logs and executes in the slave. Here you see only one piece of information, so the thing that came from the master, but not what was executed in the slave. So for this reason, the show slave status in MariaDB is inferior to what we have in MySQL 5.6 and 5.7 and 5.8. Sorry, 8.0. What do we have in the MySQL schema? We have a table where you will see the latest latest transactions that were processed. So it's using GTID, but you don't see the corresponding relay log and binary log position. So in MySQL, you have only the binary log and relay log information, and in MariaDB you have only GTID. There is no place except in the show slave status where these two pieces of information are together. So we have a GTID that is implemented in MySQL and MariaDB. What can we say about that? In MySQL, I wish it was active by default, and it was, instead of using UUID, something that is simpler to use by humans. And more integration. We'll see more when we discuss the specific monitoring. In MariaDB, it's friendlier, but the information for monitoring is really, really small. So there is room for implementation, for improvement. Monitoring. As we have seen briefly before, there is a trend towards using tables for monitoring instead of using show slave status. At least this is the intention, but we are not there yet. So let's see what is available. Up to MySQL 5.5, in the slave, we could do show slave status, and in the master, show master status. In MySQL 5.6 and 5.7 and 8.0, we have tables in the slave, and we have several tables in performance schema starting in MySQL 5.7, where almost all information from show slave status is available. Unfortunately, in the master, there is no change. So everything comes from show slave status or looking at the variable global GTID executed. MySQL tables, we have seen one before. There is one table that replaces the table master info and another that replaces the relay log info. These tables are very important if you want your replication to be crash safe. So if you enable replication using this table instead of the files, it means that after a crash, the position of your replication will be contained in the database instead of an external file. So since InnoDB will recover uniformly, your replication will continue without hiccups. But as I mentioned before, these tables were not created with GTID in mind. So what do we have in performance schema? We have several tables that combined should have all the information contained in show slave status. We have everything except the executed GTID. That's not entirely true. You have the executed GTID if you are using parallel replication, because what happens is replication connection status gives you the information about what we have received, and replication applier status by worker gives you the information about what we have executed. However, if you are not using parallel replication, you don't have this information, and you need to rely on the variable GTID executed. In MySQL 8.0.1, we have a lot more information. So in replication connection status and replication applied status by worker, in addition to what is available in 5.7, there is a lot of timestamps that tell you what happened to that transaction along the way in its travel from the master to the slave. We are going to see an example later on. MariaDB, so the situation up to 5.5 is the same for MySQL. The situation in 10.0, we have one table in the MySQL schema for the slave and nothing in the master, same as in MySQL. So compared to MySQL, the tables related to replication for MariaDB are really, really poor. Okay, so the tables in the slave in the MySQL database, relay log, as I said, you have information about binary log positions. And then the slave master info is the replacement for master info file. In the performance schema database, we have a couple of tables that give you basic information about the applier. For example, replication applier configuration will tell you about the delay. Applier status will tell you something about the channels. Applier status by coordinator tells you more information about the user that is set for replication. Basically, is the upper part of what we have in show slave status. And the important thing is replication connection status. So this contains the data that is arriving to the slave. You see, there is a received transaction set, and this is the data that is being added to the relay log. Unfortunately, there is no corresponding information about which binary log and relay log this transaction is. In MySQL 8.0.1, the previous table becomes like this. So you see that you have a lot of timestamps that tell you when the information arrived. So you still have only the information about what was received, but you know exactly when it was received a change status. So monitoring in crash save tables, what can we say? The slave is crash safe, so good. There is no replication information for the master in tables. Now, this is not strictly needed for being safe, but it's something that I have been asking for since 2006, because having the information in a table makes monitoring easier, because you can use a select statement instead of a show statement. There is a split information about received and executed data. Basically, if you want to have the full picture of what is happening in the slave, you still need to use show slave status if you want the information in one place. Otherwise, you have to query two tables or to query one table and one variable. In MariaDB, as we said before, we have insufficient information for monitoring. And also in show slave status, we don't have everything that we need. Multi-source replication. What is it? It's the dream of DBAs. So it's a way where everything is a master, or you have many masters. So you can insert data from everywhere. It has been implemented in several tools. Tungsten Replicator in 2009, MySQL 5.7 in 2015, MariaDB 10 in 2013. Everywhere has been implemented in a different way. So MySQL 5.7, we have the concept of channel. So instead of having one stream of information, we have several ones. So when we do change master to, we do change master to for channel and the name. Show slave status for channel and the name. And basically, you can do everything for this particular channel. You need to have GTID for this to work, which is good, because playing with multi-master without GTIDs is really bad. So let's see an example here. Change master to, you see for channel and the name of the channel, and there is a master auto position equals 1. So you don't need to say, go to this binary log and position. The server will figure it out on its own. MariaDB, this is a similar implementation, but different. So the syntax is not the same. So if you have tools that work with MariaDB and MySQL, you need to have different syntax. This is the same command for MariaDB. So change master, you put the name of the channel at the beginning, and then you say master use GTID equals current pose. And the confusing thing is that you say start slave S1 foo, which actually is the name of the master, not the name of the slave. So anyway. Until MySQL 5.7, the only way of doing multi-master was circular replication with full slave replay, meaning that you start putting data in one host, it will be replicated in another host, then it will be replicated again and replicated again. Instead, using multi-channels in MySQL 5.7 and MariaDB 10, you can have point-to-point replication, meaning that you don't need to pass from one server to another to get to the other servers. You can just have point-to-point replication, which means that you have more traffic in the network, but this is much faster and resilient. So if one node drops, replication will still work. So when you do multi-source replication monitoring, you have a show slave status, and instead of having only one record, you will have one record for each master. And you will see something like this. So there are 4 nodes. Retrieve the GTID set is the one that counts here. Execute the GTID set. It should tell you only the 3rd one, but it tells you all the GTID sets that were executed. So this is one thing that makes dealing with multi-source replication a bit confusing, because there is no clean differentiation between the channels. So you have 4 records in show slave status, and all 4 will have this the executed GTID set. So you kind of don't know where these things belong. And notice that I'm using MySQL Sandbox that will create these fake UIDs here that are human readable. But in reality, you will see something that is not, that doesn't tell you immediately which is which. You need to have tools to filter the GTIDs and tell you to which master they belong. In show master status, you have a similar thing. So show master status should have only the information of the data that was produced by this master. Say, I have made the transaction with UUID all once, and why do we have the others as well? So here we are mixing the data that was produced in the master and the data that was received by from other masters. So what can we say about the multi-source replication? You can run multi-source replication in both MySQL 5.7 and MariaDB. Not only that, but you can create complex topologies. So you can have star topologies, or point-to-point topologies, and fan-in topologies, everything. Show slave status has one entry for each master. This is good. Monitoring tables will have many rows, one row for each master, and this is also good. Unfortunately, there is mixed information about the data created and the data received. So this can cause some problems. Again, can do much better. So we have the same issues that we have for single stream, but since we have multiple channels, it becomes a bit more confused. GTID info is repeated as a group for every channel. We have seen that. And show master status repeats, mixes up the information about the data created and received. MariaDB, same thing that we have seen for MySQL about the single stream. The syntax is different from MySQL. I don't know whose fault is it. It's good that we have show slave status with multiple items. Also in MariaDB, the GTID info is repeated as a group for every channel. And GTID in show slave status includes data created in the server. Parallel replication. Parallel apply is the ability of executing binary log events in parallel. This is useful when you have the master that is multi-thread and has a lot of transactions at once, and then you want the slave to catch up, so not to run one transaction after the other, but to run many transactions at once. It was implemented the first time in Tungsten Replicator, Replicator in 2011. Then it was implemented in MySQL 5.6 in 2012, and MariaDB 10 in 2013, and then improved in MySQL 5.7 in 2013. It has been improved again in MySQL 8. So very briefly, we have the master that is able to treat many transactions in parallel, and with regular replication, you send the transaction one at a time to the slave, so the slave eventually will lag. When we run parallel replication instead, we have a process in the slave that will spawn several threads that will treat the information differently depending on how we said that parallel replication should work. For example, it can work by can be split by database, or can use the logical clock that deals with the information set in the master to allow the slave to parallelize information more or less in the same way that were run in the master. So implementation in Tungsten Replicator, this was the oldest thing that was done with schema boundaries. It was very fast. It is still very fast. It's only useful if your information is run in several databases and your data is more or less equally distributed in the databases. The good thing is that there are extra information for monitoring and is fully integrated with GTIDs. So this one, in MySQL 5.6, we have the same implementation that we had in Tungsten. So it's schema-based, requires both master and slave to be the same version. but there is no integration, there was no integration with GTID and no extra instrumentation, meaning that you can see the information about which relay log file and position were in each thread, but very little more. In MySQL 5.7, we have several improvements. So it's not schema-based anymore. Using the logical clock, the master tells the slave how to do the parallelization. There is more monitor information in the performance schema. It could be better and has been improved in MySQL 8.0.1. The thing that you should be careful about is if you are running multi-source and you enable parallel replication, you enable parallel replication for all channels, whether you want it or not. So you cannot say enable parallel replication only for this particular master. You have to enable for everything, which means that you will have a lot of threads, whether you want them or not. In MariaDB is a similar implementation, even though the technology is different. It's integrated with GTID, but as we have seen for a single thread, the instrumentation is limited. Good thing, you can choose to which channel, for which channel you want to implement parallel replication. Parallel replication does not work always as you expect. So it depends a lot on data distribution. So there are cases of particular loads that don't work the way that the DBA is expected. So we have the claim, parallel replication for MySQL 5.6, 5.7, 8.0, and MariaDB. The assessment is, yes, we have parallel replication that works fine. The performance is fantastic. However, the monitoring in MySQL 5.6 is next to non-existent. In MySQL 5.7, a bit more. And in MySQL 8.0.1 has been improved. As I mentioned before, you have the information in one table about what was received in the relay logs, and in another table about what we have executed. Here, show slave status don't help you because if you have several threads, you need to see the information thread by thread and not everything at once. MariaDB 10, the performance is very good. The instrumentation is bad. It's like driving in the dark. I wouldn't do that. Finally, group replication. It's a new thing that has been released as GA recently. Requires MySQL 5.7, 17 or later, or MySQL 8.0.1. It's the basis for the high availability, which in its entirety is called InnoDB cluster, or you can use it as a all masters replication. So Oracle recommends it to use it in the first way. So you use it with a single master, and then you use the tools for InnoDB cluster to run high availability. However, you can implement it in all masters, and there are a few things that work and some things that you need to be aware of. So it says synchronous. What is synchronous in group replication? Synchronous is the distribution of the transactions. So at the same time, the transactions are received by all nodes. However, the execution of these transactions is not synchronous. It's asynchronous, meaning that one node will complete the transaction before other nodes, and if there is a conflict in one of the nodes, then you will have a rollback. And this also means that if you have a system that is distributed far away, the performance might not be what you expect. The biggest difference that you have between group replication and multi-source replication is that the GTID is not per server anymore. It's per cluster. So every transaction that you find in the binary log will not have the GTID of the server. It will have the GTID of the group, which is good for something if you want to use the group as a single entity. But if you want to find out where that transaction came from, there is nothing in the monitoring that can tell you. You need to look at the binary log. Show slave status is not there anymore. So you use group replication, show slave status, bye-bye. Multi-source channels that were used in multi-source replication, they are used for something different, but not to identify masters. It's logical because since we have a GTID per cluster instead of a GTID per server, also the channels are gone. So there is the goal here is to have a cluster that looks like a single entity rather than a collection of many nodes. So there are good things and bad things. The bad things is that you are losing some details that you were used to in multi-source replication. And there are more tables dedicated to monitoring group replication. What do you find? There is a replication group members and replication group member stats that tell you the information about what happens, how ready are the nodes, and what you can do with them. If you are using InnoDB clusters, in addition to that, you have one more schema. So it's called the MySQL InnoDB cluster metadata, containing 6 tables. So if you're using InnoDB cluster, you will have tables for replication in 3 places: MySQL schema, performance schema, and MySQL InnoDB cluster metadata. I think some simplification should be needed here. So I wanted to show some examples, and maybe I have 5 minutes to do that. So I have here group replication, and what you see on the screen is the information about replication group members. And it tells you the replication, the node, the port, and the state. The thing that you need to be aware of is this, if they are online or not. In this case, I deployed with all masters, so I can run one test. I run a test that creates one table in each master and inserts something, and then I query all the nodes to see what they have received. So this tells me that I have received everything, group replication works, meaning that I have 3 masters, and of course they are also slaves. So replication connection status. As we have seen before, we have a lot more information than previously in this table because we have all the timestamps. And the thing that you should notice is this. We have a single UUID. So this is the UUID of the cluster, not of any server. And the number that you see later are the transaction numbers generated in each master. You see that there is a difference of 10,000 between, or 100,000 between one and the other. So 1 to 7 are the ones generated in the first server, 100,003 to 100,006 generated in the second server, and so on. So you have a way of telling the transaction by the numbers if you have a quick eye. But you can see here more or less the same problem that we had in multi-source replication, where we had all the information from various servers in a single place. So I would say that this is a young product that has room for improvement. And I have 2 minutes for questions. Yes?
So what do you mean by async rollback?
Say that again, please.
So say that with the group replication, right, we commit a transaction.
Yeah.
But in your previous slide, you said it is possible for a async rollback.
Is it possible what?
For asynchronous rollback.
So the rollback happens when there is a conflict in the nodes. Because what happens synchronously is the spread of the data. Then the slaves, so the nodes will apply the data as soon as they are ready. And the first node applies and says, I'm done. The second one says, I have a conflict. In this case, the transaction gets rolled back. Yes. It's not that simple. Yeah. So, yeah, I have seen different slides about this process. So the first time it was explained the way that I explained here. But anyway, it's, the important thing is that it doesn't happen. It's not like in MySQL cluster where it's really synchronous. So if you have a conflict, you get an answer immediately. In group replication, like in Galera, you spread the data and then wait for the result of all the nodes to and to know if your commit was globally successful. And this is the asynchronous part. So this is the end of the presentation. If you have more questions for me, I will be outside and happy to answer, because I need to leave space for the next speaker. Thank you very much for attending.